Okay, so this is the lesson video for section drawings. This is adapted from activity 1.3.6 in the PLTW curriculum. And this is going to take you through the instructional components. And then there's a separate video that models what you need to do to demonstrate that you can do a section drawing in Fusion 360. So in the last activity, you explored how to use a plane to look inside an object that you designed, namely the screw holder. And so what I did was I pulled from Teams some examples from the last activity of how a plane was used to look inside the screw holder. And so you can see if I turn my little pointer on, this person, their screenshot, you can see the plane and it's cutting into the screw holder from the front. And what it does is it slices inside the object. So it allows you to look inside. This one was done a little bit at an angle, but you can see again, it's like cutting down the middle of the screw holder. And these lines, the diagonal lines, are there to show you that that is solid material. So you're seeing something like the solid inside of the material there. This works great within the sketch environment to inspect the inside of a design to make sure it looks okay. So if you're trying to shell something, particularly if you have something that's like hollowed out on the inside and you can't tell just by rotating the view cube around that it's what you want, you can do that section analysis and pull that plane through and say, oh, okay, this is good. This is what I wanted to see on the inside. But how can we communicate that same information within the formal drawing in Fusion? So if you're producing designs for an object, you might want the person building it to have that same look at the inside. It's going to help them when they're programming their 3D printer or when they're milling or sawing stuff, that they know this is what it's supposed to look like on the inside. So in this lesson, we will talk about what section drawings need to show, and you will do something underneath my head. You will complete a quick drawing in Fusion to demonstrate your skill and your ability to do drawings this way. The deliverables for this activity are the completed section drawing in Fusion 360 of the object in the video. It'll be worth 15 points. So you're going to need to pretty much do what we were doing with the screw holder and the colonial flag. You will need to follow along with the video and then create the drawing. So looking inside, this is a neat example of a section view. So it says here, have you ever noticed that some objects have more going on inside than out? Take an apple, for instance. From the outside, an apple appears to be fairly simple, an organic but spherical-like shape covered by a skin with a depression from which a stem protrudes. But what does the apple look like on the inside? How would you communicate the intricate details, the air spaces, and seeds hidden inside an apple to someone who has never seen an apple before? Perhaps the simplest way to communicate the internal features is to cut the apple in half so you can see the inside details. And so we have there the example of from the outside, you can't tell that there's all kinds of really important stuff going on the inside of the apple. And so you would need to actually cut the apple and probably have to cut it from a specific direction and at a specific depth to see. So if you only slice like a very thin slice off the edge, you're just going to see the meat of the apple. You're not really going to see those details. And if you cut it like up from the bottom, you're going to get a very different, what's called a cross-sectional view of the apple, depending on the angle that you cut it at. And so for this example, the best way to cut the apple is vertically down the middle, pretty much through the stem, like in the center, if you want to see all of the relevant details. So I thought this is kind of neat. So what are some real life examples of sectional views? Why is this a useful thing to know about? So CT scans provide sectional views of organs inside the body and are used to diagnose and treat many medical issues. And the PLTW curriculum does give you some pretty neat images there of like different brain scans. One is the coronary artery, and you might use a CT scan to determine if there's a blockage, to see what's going on the inside. And we have some pretty amazing technology that does allow us to do that. Fun fact, one of our engineering students did an internship at UNF last summer that dealt with brain scans and actually gave me a copy of one of the brain scans so I could document it. If you're watching this video later, this is recorded in the 2021-2022 school year. So if it's an older video, then it wouldn't have been last year. But we did have somebody who did an internship with UNF and did participate in a summer program. And that was one of the things they did. And that was even, the student said it was lame because COVID made it lame. But like a brain scan is pretty cool, no matter how you dice it. So we need to determine the cutting plane. So a cutting plane is a plane that cuts through the object and determines what part of the object we will see when we look at the section view. So you can see an example there. That's actually an axle from an older version of the IED curriculum. So we have an axle there, and you can see where that plane is. And that plane, when you look at the sectional view, it's going to show you that cross-sectional image, and you can get like the dimensions of things and really see what's going on. You could put that cutting plane at any angle coming in from any direction, depending on what it is you need to see. And that's where you, the engineer, you need to be thoughtful in how you're going to cut the object to make sure that you can see what you need to see. So this is an important slide, and you might want to pause the video at this point. When we create section drawings, we do introduce some new types of lines. So we've talked about, center lines, hidden lines, object lines. We like construction lines. We've used construction lines in Fusion. So we've been dealing with all these different types of lines. So when we create our section drawings, we're going to introduce a couple more lines, and you want to make sure you know what these are. One is the cutting plane line, and that is a thick broken line with arrows on a technical drawing that indicates the location of an imaginary cutting plane. So unfortunately, on the actual drawing, you don't have the ability to see the plane, so it's going to be rendered in 2 dimensions instead of 3D. Makes it harder to see, and view the direction used to create the sectional view of the object. So over here, okay, you can see this is a multi-view. So we have the front, we have the top, we have the isometric. Now they did not do a right-hand side of this because they're trying to demonstrate a section view instead. So right here with the arrows, okay, this is the cutting plane, and so the cutting plane is going to cut like back, if you can picture, like it's going to cut into the object from that direction. And the way that you are going to view it, the arrowheads are showing you that. So the arrowheads are saying you're going to view it from that direction. Okay, or in that direction. And then over here we have the section view over here, and it will be like numbered, or like it's got a label. So this is like section A-A, and Fusion will automatically label it for you. And then we have the other type of line, which is called the section line. These lines used in a sectional view indicate where the cutting plane has cut through material. And I mentioned that earlier, the cutting plane in the sketch environment does the same thing. And so you see those diagonal lines, and what that means is that's solid material. Okay, so you're looking at solid material, and then this would be open space. Okay, so the plane is not cutting through, and you can see like down here, if you look down here, the bottom of the cutting plane, it's like cutting through solid material, then there's a hole in the object, and so it's not cutting through solid material. That's right there. And then solid material all the way down until you get to this little notch, and then you can see it's open. And then right here, what it's showing you is that it actually, this like notch here is cutting up into the object somehow, and we can't really see it from this direction, but it is hollow on the inside, and so our section view is showing us that. So that's pretty much the new line types, so that you're able to interpret this. And notice also that it stays proportional. So like the top of the axle here lines up with the top, the bottom lines up with the bottom, the center line here is lining up with the center line. So you do need to retain all of those components. When creating the drawing in Fusion, and you can follow along, there is the demo video that's going to go with this. Choose which view, top, front, top, or right, you need to cut in order to see the cross section you need. That can be legitimately tricky if you don't visualize things in 3D naturally, and I don't. So I have to think really hard, and sometimes I'll create the section view and then have to say, oops, that's not at all what I wanted to see, and then you have to undo it, which, thank God for the undo button. So you can undo it and then try, different cross section. Choose section view from the menu, and you'll see that in the demonstration video. Place your cutting plane in the object where you want to cut through, and then drag the view out to clear a spot on the drawing. And you should have some space on your drawing. Watch the video to see what you are designing and cutting. So that is the last line there. To see what you are designing and what you're going to be cutting, and then you should be able to produce that on your own. I know for one of my IED classes this week, you might have to watch this video for your lesson because I might be pulled out of class, but we'll cross that bridge if we get to it.